I think I see your mother. I better get to work.
Hey Tim, aren't you supposed to be working?
Oh, what are you talking about? Isn't today Wednesday?
Hey Tim, aren't you supposed to be working?
Oh, busted. Oh, today's April 15th and I have to... Oh no, I don't have to mail my taxes today.
Tim?
Oh. Welcome. This is Tim Murphy of Murphy Pavement Technology. Today's webinar is going to be about what it takes to be the best quality control manager in the asphalt business. Quality control manager is the heart and soul of any organization. They need to have many skill sets, understand mix design, production, and construction. They need to be able to communicate extremely well throughout their organization, as well as with the clients who are asking to build a roadway, runway, or industrial parking lot. I'm doing pretty good here, huh? The quality control manager is going to have to know how to coordinate all those moving parts. Once you finish the webinar, send me an email and I'll send you the quiz. And upon completion of your quiz, I'll return your certificate of completion.
So as mentioned, our webinar today for essential employees in the asphalt business is going to be specific to QC managers, quality control managers. Quality control managers are being challenged to provide quality by using statistical methods. And so we will explore the important parts of the most challenging part of a quality control manager's job, specific to maintaining inputs to ensure a quality output. So I essentially titled it Managing Construction Quality Through Statistics, and certainly those who are successful are what I would consider to be the best quality control managers out there. To that end, after we do our finish this webinar, next I'm going to start planning a quality control lab Olympics. So a little bit of a lab Olympics with QC managers and their technicians as well.
I think we're going to have a lab Olympics, just like my friend Philly said he wanted to do. Are you ready for it?
Thanks for joining me. So it's a little more along the lines for quality control managers to follow along. Really gotten a lot of good input from QC managers over the years about the importance of their must-have lists with regards to studying. They have to have the knowledge, have to understand how to affect asphalt during proportioning after the mix design, and once they're into full production, understanding the reproportioning of mixtures to control it properly. But to set the table, we'll go over the 8 key elements for success. Fairly important from a manager standpoint. So the list of 8 key elements for success are really quite important. Most of you are aware of them, and it doesn't necessarily limit you to a quality control manager for these 8 key elements for success. And I think you all realize you're in the position that you're in because you've adopted these and you adapt to how to ensure you integrate all of these into your workforce of many generations of people from 18 to 80 work in the quality control industry, and certainly within the asphalt industry itself. And always be truthful. Similar to one of our last webinars where we talked about the golden rule. This is very, very important. Sharing of information across lines, up the food chain, to your employees. That way we can all make really good decisions to be successful. Kind of broke them into different parts of grouping of the elements, as we call them: foundation, building bricks, the mortar, and the roof. It's equally important for each and every item, but don't forget about, again, good communication. And for all of us to, we're all humans. We like to be recognized for good behavior and successes. And it's one of the really nice things, again, about those NAPA, National Asphalt Pavement Association awards we talked about last time, is they do a very good job and recognizing companies for putting together quality and construction projects. But they really, the quality control manager has a major role in being able to achieve that level of success. So the QC manager, defined by me, is going to be the point person for everything. They should be listed in the quality control plan. They should be the person who trains their personnel, decides what needs to be done. Certainly there are qualification and certification courses in most states around the nation, but there's additional training that can be done to help their employees move along, both by the Asphalt Institute, National Asphalt Pavement Association, National Center for Asphalt Technology, and don't forget, next year World of Asphalt will be coming back as well. Just really good opportunity to train people and cross-train them to understand other people's jobs and expectations. It'll help make the whole team better. QC manager needs to be incredibly strong with production operations. A QC manager who's weak with the production operations will fail. They need to really understand how asphalt plants work. They need to understand the challenges of the asphalt plant. And they also have to be able to manage the production operations and personnel to ensure that they know what rules to follow to ensure a high quality asphalt is produced. They're typically going to be determining pay factors on a project after they get test results, and they'll be coordinating those pay factors with the agency that they're working for. And they're always both interpreting quality control specifications as well as helping industry and agencies to develop future quality control specifications to help improve asphalt pavements. Quality pay factors is a reflection of consistency and accuracy. A contractor can produce product with a very, very narrow range of test results, but if they don't target the correct location, they could fall off and in some cases be below the lower limit or above the upper limit of pay factors. So paying attention to the target, I'll call it a job mix formula or a contractor's job mix formula, and then the consistency towards that target throughout the sublots. And then you end up with typically a lot pay factor, and number of sublots and whatnot that go into a lot vary from state to state, but they're significant. They could be as low as 4 and typically as high as 10 sublots for each lot of material. So you can see here, this is really not consistent from test 1 through test 9. This is also a graphic that shows you how maybe 9 different contractors actually perform under a quality control or pay within limit specification. So again, typically we want to have very narrow range of results, and we want to make sure the target is as close to the middle as possible. Quality control manager's must-do list is always evolving. Planning and communicating are very important. Organizing personnel, what time they should show up, and what activities they should be performing throughout the project. The quality control manager needs to be intimately involved in input products so that they can anticipate adjustments. We call that controlling the process, and make minor proportioning changes as needed. They need to lead by example. And similar to before, quality control manager needs to learn how to command respect, not demand respect. Staffing challenges do exist, especially in the summertime when we have day and night work. And so the quality control manager needs to staff accordingly, whether it's with employees for the asphalt producer or by reaching out to local consultants that have the talent pool to supplement on an as-needed basis. QC manager's job's never over. It's almost a 24/7 job throughout the summer, and that's the sign of sorry, we're open. They are always, always involved in the success of an organization. They really are the heart and soul. A good quality control manager is the heart and soul of an organization. Some quality control tools we have available to us. Pareto chart, check sheets are fairly simple. Control charts, upper and lower, that would be very typical of a specification requirements. Flow charts, or what you might call run charts. Histograms, which are frequency and versus the results that you're getting. And then there's scatter diagrams, which is very typical for nuclear density gauge versus core comparisons. One of the tools that a QC manager can use, and actually any manufacturing facility can use, is a Pareto chart, named after an Italian economist many, many years ago, that will demonstrate from left to right the amount of defects. The taller the bar graph, the more the defects, ramping all the way down to the least amount of defects, but the sum is going to be 100. And so in this particular case, you can see, this is just an example. Lack of action when variability exists is a very common problem in the manufacturing of products. Aggregate variability in some sources can be incredibly high testing error, whether it's on the contractor side or the agency side. Still, unfortunately, a very large portion of our defects in asphalt with testing variability. What's going on at the asphalt plant? Is it properly lined out, calibrated, and whatnot? And certainly misinterpretation of specifications can also do it. So the red line that forms essentially runs up to 100% defects. So if you had 100 defects and you summed each of these individually, that's how it works out. And then you need to decide which ones need to be addressed first. Why does lack of action occur so much? What's the ramifications, the penalties, and whatnot? It's a very good tool to use to be successful against a Pareto chart. Simplest form of getting data into a Pareto chart is a quality control checklist. So it could be somewhere on an interstate somewhere, and variable problems come up. And then you need to pay attention to the frequency of how often they come up, and then usually kind of tag it with who you need to talk to resolve these issues. Maybe it's an individual who's a foreman or a superintendent. Maybe it's a plant operator. Why do we have certain problems? Is it a design issue, -200, the breakdown? Is your plant properly set up to do positive dust control? Did you do a mix design that properly anticipated how much dust would be in the mix? Segregation has been a topic that I've done training on for my entire career, and unfortunately I continue to do it as it continues to rear its ugly head for various reasons that we'll talk about later. And a compromised ride. Was the paver properly set up? Did the superintendent set the job up correctly and use 2 skis when required on a project, or did they elect to use a joint matcher, which is going to cause nothing but problems on a project? We talked about that in the last module. I just want to continue to repeat some of the things that continue to be problems in our industry, so please pay attention to those. Quality defined from Japan. Different individuals came up with commentary on quality and which one applies to you and what makes you feel that quality. Yeah, that really sounds like that's why I think quality is important. The aesthetics could be an issue. It certainly is in commercial parking lots. That's a major part of the quality measure they have. They don't know what asphalt is. They certainly don't know what gradation is, but they can definitely look at and see if your joints don't match and if the texture of the asphalt is smooth or not. Another quality defined from a TRB circular, I think this is a really good one from Circular 457, is it's the degree of or grade of excellence of a product. And is the customer satisfied? Yes or no? And to what degree? If they're really happy, we call that an A+, and you're going to get paid maximum amount, which might be 105% in a pay factor. And then the degree to which a product conforms with a requirement. So there are requirements for oil content, strength, voids in the mineral aggregate, Hamburg testing, crack testing. It could be the prettiest, smoothest ride ever and have great density, but if it doesn't have the right ingredients, there might be a penalty. So there's an awful lot of things that go into this. So I applaud the TRB for putting this definition of quality out there for all of us to follow. I hope you adopt it. I hope you adopt the quality requirements we talked about. Then your job gets even that much more difficult, because it isn't just one asphalt coming out of an asphalt plant. We have transition mixes. That means that we're going to be making some asphalt for a local agency, and then maybe we'll flop over to an interstate and then back to a commercial and vendors who come in and pick up asphalt. This is very challenging. Transition mix is probably one of the largest reasons we have failing test results in asphalt, is lack of a plant operator paying very close attention to the transition from mix 1 to mix 2. Probably, again, the number one reason for failure in test results is transition mix. We have a lot of different asphalts around the world. We could have very low ADTs. We can have very high ADTs, average daily traffic counts. We're going to have a lot of different asphalt mixtures for each type. Might have a big stone, might have a little stone, might have a coarse aggregate, might have a fine, coarse gradation or fine gradation. Could be a dense graded asphalt, could be a stone matrix asphalt. Lots of different characteristics are required because asphalt is so phenomenally flexible and you can use it in so many applications, but you need to make sure that you use the right mixture in the right application for success. We wouldn't want to put a low volume shoulder mix on a mainline truck route in the middle of a city. In this case, you can see flushing that's going on. Quality control investigation in this particular case, couple things. A little high in dust, a little high in AC. Compaction results were extremely high, so the quality control manager should have known, and they were north of 97% of max gravity. And the mix that was used was a lower gyration than desired. So it was a triple whammy in this particular case. Only flushed in one direction because that was the two things. That was the day that they paved with those ingredients being a little bit high on dust and oil. It's also the way out of town where the trucks were fully loaded. So you could potentially have different characteristics based on the loading of the roadway. I think you all know that. So a little more on total quality management. From Deming, learning is not compulsory, but neither is survival. So it's very important for us to adapt to our changing environment, adapt to the specifications we work under. Most successful asphalt companies are going to be the ones who can figure out how to put all the puzzle pieces together, how to build teamwork in the different silos between crusher operations, asphalt plant production facilities, estimators who bid the job, the paving crews, truck drivers, inspectors, and owners. You need to be profitable, but you have to be compliant. And everybody on the contractor's team needs to understand and pull in the same direction. Really don't want to be working independent from one another. This is a nice puzzle, how all the pieces fit together and they work together. This will be the most successful company. what are other things you need to manage to be successful in road building? Innovation, research. You need to continue to research. Hire experts to come in and help you out from time to time. Upper management is crucial. Technology, marketing, it's never ending. There's just a never ending list of items where we can put efforts forth to be more successful in building asphalt pavements. You have someone on your team who can bring that clarity to that chaos. And Deming, again, was what some people had called kind of the godfather of total quality management, and he brought it to different organizations to help out. Most of us have adopted some form of total quality management that matches the needs of our organization. That's really important. So it's not an outcome. It's a never-ending process of continuing to tinker and improve the quality that you're capable of producing. And when you're very good at targeting and reducing the spread on your test results, you will be the most successful contractor, and you'll be able to bid jobs tighter, win more jobs, and again, repeat, build and get bonuses. One of our daughters, it reminds me of a story of one of our daughters when she was very young in kindergarten, and she was having simply back pain because of the backpacks, and a lot of kids have had these challenges. And so it's a typical example of what they call a fish chart. So you look at different things: the design of the bag, the school environment, how large are the textbooks, the size of the student, things like that. So this is just as they call a herringbone or a fishbone diagram of a lot of inputs, a lot of variables. And once you have identified the problem, you need to quantify the problem. Once you've quantified the problem, you need to solve the problem. And I like to call that your IQs. Identify, quantify, and solve. An overview would be to ensure you do not die from too much data. You need to understand what's relevant information, what's useful. Some organizations present me with stacks upon stacks of data. Much of it's useless. They don't know what to pay attention to, so they just accumulate everything. When you do that, you're not going to be able to make a good decision. There's just too much information. So you have to really break it down and understand what the most important information you need to do your job is. Everybody, everywhere, every organization has processing errors and shortcomings. We need to continue to train our employees. We need to continue to audit and review our processes. We need to continue to improve upon them. Giron defines quality as fitness for use. All right, that's fine. Deming said, hey, quality should be aimed at the needs of the customer, present and future. Either definition's fine. The customer decides what they want, what quality they want, what they're willing to pay, and then they don't participate in the process that creates the product. That's very similar for our asphalt industry. Specifications are written. They're going to require certain volumetric measures, certain strength measures, stripping measures, cracking measures, and then the contractor will put a mix design together with the ingredients that are allowed by the contract documents, and then they realize there might be some variability. So they might build a little shock absorber into their mix design, so if there's any variability, all of their test results pass. That's going to be the definition of an excellent contractor. Excellent contractors can only be known as excellent contractors if they have a very good support team, and in particular, the quality control manager leading that support team. We do need to have buy-in by the plant operators as well. We need to continue to educate and assist our contractors, our construction part of our contracting arm, to do a good job in smoothness and in density. So TQM is, it's just, it's based on the idea that the feeling the impact of the decision should be involved in making it, okay? Those feeling the impact of the decision should be involved in making it. So empowering employees is going to lead to the greatest amount of success. All right, it's a very, very profound principle, and that means sharing knowledge, sharing data, and don't hold back things. So what are your corporate critical inches for today? What if I were to pause this webinar and say, hey, send me an email? What would your corporate critical inch and goals for today be? What's going to make you better? I think that there's a delineation between people who are what we call inspectors, samplers, and testers, and then the next level of somebody who can analyze the data, adjust, and anticipate what's going to happen. I honestly believe some people spend their entire career in the first level, and then they're asked to become quality control managers. Those are quality control managers that fail. Those who really understand how to analyze, adjust, and anticipate will be the most successful quality control managers. So back to inspection. Inspection begins at all of the facilities, typically the aggregate quarry, works onto the asphalt plant. Then we grab samples from the field as well. We need to look at stockpile. We look at equipment maintenance needs. Need to make sure that we're not introducing variability that does not need to be introduced. We need to be on top of these things. We need to continue to draw and do our job, draw from others' experience from the start of the season to the end, because these things can unfortunately occur at any given time if we're not on top of our game. Know where to sample, know how to sample, understand aggregate's specific gravities. The color of an aggregate can change, and so will the gravities. Understand that reclaimed asphalt pavement needs to be processed and handled appropriately. And understand that when you put a mix design together, you should introduce breakdown into the mix design, because all of the aggregates will break down as they travel through the drum. If you introduce a little bit of breakdown, it could come from the bag house. Introduce that. That's going to help to make you incredibly successful once you go into production. And let's keep after our moisture contents, both in the aggregate stockpiles, but also at the point of discharge from the asphalt plant itself, because we should probably not have more than 0.3% moisture in our asphalt mix at the point where the asphalt comes out of the drum. If you have excess moisture, you're going to have asphalt cooling too quickly, and that's going to present a problem. This is just a picture, I believe, from NHI, just showing that a very large quarry and a lot of different products that can be manufactured. So we do have to pay attention to the production rates and gradations of the products as they're built into the stockpiles. Storage at the asphalt plant is very important. This is an asphalt plant that shows nice division between the different products, and certain products are also tarped to keep them dry as needed for good production. It would also be a place where you would grab the gradations, test for gradations of the aggregate products and moistures as well, the different stockpiles. It's early morning for a quality control technician, that's for sure. It's that typical sketch of the flow of material at an asphalt plant from the cold feed all the way through the drum. Storage and belt scale, we have to check, make sure that it is calibrated and meets our tolerances on a daily basis. And then the aggregate will usually be measured on finished product out of a truck or from behind the paver, but you can also check not just the stockpiles, but you could get it off the main weighbridge as well. Pay attention to how asphalt comes out of the drum. Is it flinging coarse aggregate too far, as in this picture to the left the coarse aggregate was going? So we put a kind of a blocker in the way to force the coarse material back into the flow of the asphalt to mitigate a potential segregation problem. Again, do you test it behind a paver, or do you grab a sample out of the truck and then shuttle the material back to the lab as quickly as possible? We want to perform our asphalt contents and gradations. We want to do volumetric testing with our maximum gravities and bulk specific gravities. Sometimes we'll do Hamburg testing, sometimes crack testing. Awful lot of tests go into qualifying product, and when they're consistent, the material is excellent, and if it meets the proper specification level, it's going to last a good long time. Remember, we're trying to do process control and build asphalt that's going to last at least 20 years with appropriate maintenance techniques. So we're going to look at, again, the target, the standard deviation of the product, and there's different things that come into it. Some of you have heard the phrase Six Sigma, which talks about standard deviations below and above the mean that we measure for producing asphalt. And we're always trying to improve upon that. So there's an inspector Jeopardy where the answer is sampling and testing personnel for 500, Alex, who are personnel that understand and appreciate the meaning of the word random. So random is very important, especially established by the State Highway Authority and the Federal Highway Administration. So we have to make sure that we don't do biased testing when we're accepting large amounts of material. So very important to understand random testing. Random testing, it just means we're not going to have, hey, I'm going to take a sample every day at 7. We're going to figure out how much material we're going to produce in a day. We're going to divide it into sublots. And we're going to randomly generate numbers that tell us, hey, what truckload should we grab and what offset should we grab it from? So you might know it as station and offset. Some agencies still allow you to grab samples during production at the asphalt plant or out of a truck. So just follow your agency specification for grabbing samples. It doesn't preclude us from grabbing biased samples. That's to help us define what went wrong. But random is really used to accept material on large amounts. So that's why it's important to understand what random is and its value, and understand what a biased test is and its value. We need to focus on quality and prevention of problems and do our best to not just live the life to be reactive. So a good design, a good mix design is going to go an awful long way to mitigate variability that's inherent and keeping a test result from being determined or called defective. Contractor needs to know their ability to produce product consistently. That is exactly how you're going to be successful. When you're successful and you get awards, the marketing and the customers just flow. That's another really good reason for getting contractor quality construction project awards. Many states do it. I've been to the Indiana Asphalt Pavement Association's meeting several times, and they give out dozens of awards for contractors who do excellent work. These are definitely your calling cards for future work. So please participate as best you can in applauding your competition, but also challenging your own organization to a higher level to be successful. Major elements in the solving and prevention cycle. Yes, we need information, but it needs to be useful information. We have to analyze before we take action. We have to understand cause and effect of things. If the dust is 1% high, Well, voids in the mineral aggregate is 1% low. And in that case, air voids is also 1% low. So we have to understand we're going to always adjust our voids in the mineral aggregate with aggregate gradation, particle shape, and surface texture. We can adjust voids with asphalt content, but first we want to get our VMA in order, and then everything works itself out. Use brainstorming. Get multiple people together if you don't know the answer. Try to reach back on people who've had experience in the past, and maybe it's the same answer that solves it for the future. We always want to be evaluating so that we're successful. Do your best not to get complacent when everything's running along smooth and true. It doesn't mean you should give up on doing auditing of yourself, auditing of your employees, and checking of all of your equipment. That's how you stay fine-tuned. Establish, display, and use control charts. They're wonderful. Put it up on the wall. Let everybody see it. It's a proud moment, or it's not a proud moment. Plain and simple. You just can't hide it. But it instills awareness of quality by placing it in front of people. It allows you the opportunity to mentor and teach your employees about statistics, about process control, about the value of quality. If you see it, it also does encourage you to have timely reaction, because sometimes you can make an adjustment and prevent non-conforming material from going to a job. You may be able to redeploy it to a different project where it is compliant. These are all really good things to help you make good decisions. But you, again, need to know what measurements are important. And too much data is just going to bury your quality control manager and you won't be successful. Trend towards the target almost in every case. Understand you have a maximum tolerance above and below. Hammer on your suppliers all you want. Look at your data. This is a run chart on the -200, the dust. It shows that there was a spike on a test result that went upward. Well, if density didn't change and the volumetrics didn't change, well, this is just a flyer. You cast it aside, you grab another sample, and you test again. But there's always cause and effects. If the dust had skyrocketed and the VMA collapsed and your compacted gyratory specimens became greasy, I'm fairly certain the asphalt was shoving around under the rollers as well in the field, and you would have heard about it from multiple people. So every cause and effect, they work together extremely well, and you should be aware of them. That's what I call good measurement, reasonable measurement, and understanding the product best. Use run charts for individual tests and use run charts for averages, typically 4 or 5. That'll demonstrate what you're doing. Are you reacting? Is there a trend upward or a trend downward? On the individual tests here, this is not a good example of a system that's in control. Measures go high, measures go low, and then when you take 2 or 3 of them, they have a tendency to average themselves out. If you look at test number 8 and test number 9, old specifications would have said, well, take 8 and take 9, add them together, divide by 2, and if you did that, it'd be perfect. When the reality is we have 2 test results that are significantly out of specification, one on the lower and one on the upper. So do pay attention. Do pay attention to that data. It needs to make sense. Statistics are a wonderful thing that help decision makers make good decisions. It helps to avoid knee-jerk reactions. It helps to understand systematic factors and how well we can actually perform our job. If we don't pay attention to statistics, it'll significantly affect our product and service quality. They're all very interrelated and intertwined. So spend a little time on your specification. Make sure you understand the pay factors and the statistical process control required. Organizational realities and individual realities have to be matched and mated together. That's where quality management realities collide, and we want them both to be extremely high, and we want you to be extremely successful. This doesn't come free. Human resources has to continue to help develop quality control organization, the entire organization, but since we're talking about quality control managers, in particular the QC manager and their staff. Organizational development, working with human resources, is going to give you the best team possible. Relationships between causes of low customer satisfaction are many, and many of them are intertwined. You could give the customer a lousy mix and an incredibly low price, and for a period of time they might enjoy it, but the performance is going to be terrible. And those who install that asphalt are going to start losing customer and client base because the asphalt might segregate or the asphalt might ravel or crack prematurely. They want a product that can get installed. They want you to be able to balance high price and low price. They want the right price, and they want it to last a good long time. State agencies do an excellent job on specifying and demanding a mixture that's going to perform for many years. They'll use polymers to help asphalt out. They'll make sure there's a very good mix design and rugged performance tests such as Hamburg testing or some type of crack testing. They pay a little more, but they have to because the roads carry so much traffic. And it's the lifeblood of our society. We want those pavements to last a good long time. Big box stores are starting to understand the value of quality control and quality assurance, and they're starting to gravitate from less is better. They're definitely gravitating more towards higher price, but also higher quality. It's what they want, it's what they spec, it's what you should deliver. Improving customer satisfaction, again, comes to good quality product, competitive prices, and obviously they love support. A lot of items go into helping a contractor be at the top of their game. You can't reduce prices if you don't have increased market share. You can't increase market share if you have a product that isn't good. And the only way to ensure your product's good is to have quality control testing going on. There's a cost to that. The proper staff, the proper training, making the proper decisions. And then throughout the whole thing, we have to really improve our customer support. We have to explain to them the pros and cons of quality control and the product that they use for their facility. Again, quality control managers control this part of the improvement plan 100% in my opinion, but they need upper management support to hire and train the correct employees for the job. Balancing everything is the quality control manager's job. They need to understand how much the facility can produce, what products they're producing on any day. They need to provide the service to the paving crew by watching installation practices for both smoothness and density. They have to understand trucks need to be of high enough quality. They need to be tarped. They need to be clean, smooth beds. Quality control manager is going to be walking the yard a lot, looking at stockpiles, looking at equipment, looking at manpower and how they're doing their job out on the roadway. A good quality control manager is almost never in the laboratory, but they're trusting their number one technician to do the sampling, splitting, and testing of the asphalt accordingly. Quality control manager has to be available at all times. Quality control manager needs to be mature and available and concise. They need to direct people on what is going right and what is going wrong. They need to insist upon consistency. They need to watch out for segregation or using the wrong product. And a quality control manager is always going to dialogue with both the estimator and the owner, and that it takes more than a couple of weeks to get a mix design done in today's environment. So Pay attention to what you're crushing. Keep it consistent for the mix design, and ensure that you include a bit of breakdown for the material in the mix design phase. And for goodness sakes, watch out for designing a coarse gap gridded mix that is just prone to segregate. A much smoother S-shaped curve is really what's desired. In general, a good design is going to have a gradation that falls within 10%, maybe 8% of the primary control sieve when the primary control sieve is on the maximum density line. The tolerances allowed by ASTM and AASHTO are too wide to be successful, so don't go to the highest and lowest points. They will get you in trouble, and they do increase testing variability. A good contractor quality control manager is going to know that. Good contractor quality control manager is going to take it upon themselves to be trained in mix design. The Asphalt Institute has updated MS2 asphalt mix design methods. They do mix design training around the nation, as do other people. A good quality control manager who hasn't been through a quality control mix design course by a good instructor, well, they're a good quality control manager. And I always like to say, why let good get in the way of being great? So I'm going to applaud those quality control managers who have been through a mix design school, and I'm definitely going to applaud those who decide to go through again, just as a refresher. And finally, the best quality control manager is going to teach their employees good asphalt mix design techniques, review their work, coach them, and encourage them to do a good job. So I've put the Asphalt Institute's website up here for you for reference. If you want to purchase their book, please do. It's an excellent manual. The winner of quality control, the winner of my soon-to rollout, I want to have a Lab Olympics, is going to be an individual who knows how to analyze, adjust, and anticipate what's going on in the yard, what's going on in the field, and how it all ties back to the mix design that they built prior to the project beginning. To set yourself up for success, a quality control manager should insist upon a test strip 100% of the time for new asphalt mixtures. Whether that goes on the job, or it goes to an off-site test strip, or a commercial project, personally I don't care. You should do it. You should not design and go into production without doing an acceptance test strip. Here are some different pictures, just showing radial stackers that help with stockpiling of aggregate particles. Pay attention to good load-out techniques, both at the quarry as well as at the asphalt plant. Look for segregation, look for fine areas, look for coarse areas. That's going to present big challenges to your process control if you're not aware of it. And good load-out techniques, it doesn't come easy. Good high lift operators are going to do a wonderful job for you if they know what they're doing. Sometimes it's just a little bit of training that they require. Quality control manager can teach the plant personnel. This is a perfect example of missing dividers where product is contaminating from cold feed 1 to cold feed 2. Cold feed 1 even looks like it has a Christmas tree in it. It's just very sloppy and really should not occur. Quality control manager needs to be on top of these items. Visual. You can all look at this and say, yeah, Tim, that's aggregate, that's coarse and fine aggregate going into a drum. But pay a little closer attention to it, and you'll see that the actual material is segregated. It's fine on this side, as shown in red, and it's coarser on this side, as shown in blue. Well, that's going to be an introduction of segregation into the drum, and that is going to compromise your heating and drying of the coarse and fine aggregate particles. That will compromise the output. So we want to do our best to look at the aggregate flow all the way through the asphalt production facility. to have a pre-pave meeting. We want to look at the equipment, make sure it's properly set up. Make sure we have auger extensions in, tunnel extensions. Make sure that the vibrating screed's working. Pay attention to how many rollers are needed, the width, the weight, the unit total applied force. Again, the acceptance test strip is going to be a wonderful time to develop a growth curve to determine how fast you can actually pave. Quality control manager needs to be involved in the pre-pave meeting 100% of the time. Some miscellaneous details. Pay attention to how you overlap your joints. This was a test strip where the overlapping of the joint was crushing stone. Fortunately, it was on a lower lift. It was not the surface course. I think most of you would know this is unacceptable work. Pay attention to how trucks empty. Look at the asphalt in the hoppers. Look at the asphalt out of a belly dump. Clearly you can see the coarse material and the fine material are not together here. We call that a rock pocket. It's most certainly going to show up out on the road in low density and a compromised ride. Quality control managers at asphalt plants and laboratories sometimes aren't 100% in tune with how asphalt plants work. Quality control managers need to know how asphalt plants work. Quality control managers need to know how all of the equipment works. Rollers, pavers, and the trucks. Quality control managers need to work extremely well with the superintendents of construction to help them do the best they can on their projects. So again, our summary is to make sure we have good technicians who are properly trained to inspect, sample, and test the asphalt. Quality control managers need to know how to analyze, adjust, and anticipate problems. But all together, it really takes a lot of teamwork to be successful. And so a quality control manager is really only as strong as the organization allows them to be, and only as good as they challenge themselves to be. Different producers have different products. Producer A or Producer 1 has the higher quality because it lasts longer, plain and simple. Which part of this curve do you want to be on? Because of this is why most agencies pay contractors according to their process control and whether it's excellent, good, fair, or poor. And in some cases, if it's poor enough, not only would there be a pay deduct, but they might actually have you remove and replace the asphalt. Those are pay within limit specifications that exist. Those are pay within limit specifications that are just. Agency and industry need to continue to balance those equations. Industry needs to continue to overachieve and get paid the maximum they can in every case. It's going to come from training. It's going to come from experience. It's going to come from a good quality control manager who knows how to reach out, ask proper questions from people within their organization, ask questions of people in industry who are their friends at the meetings. But we need to tie all parts of an organization together, and that really is a very difficult job. And it's the quality control manager's job to do it. The most successful company is going to have an excellent quality control manager. Our next webinar, per your request, is going to deal with essentials of a mix design, production, and construction in greater detail. However, concurrent to that, I'm going to be launching I want to have a Lab Olympics. I'm going to expect a lot of fun. We're gonna start out coast to coast and whittle our way down to a couple of champions and see how well they do. So thank you for your time in listening. Please remember to email me and I will send you your 10-question quiz. When you return it, please send some additional educational topics for the essential employees that you would like to hear about it. When you submit your topic in your exam back, I'll return a certificate of achievement for you.
Thanks for participating. Stay safe. we're gonna have a lab Olympics. Yeah, that's what we're gonna do. Are you the best? Can you